All right, so let's discuss governance in our system. I'm just going to give you an overview of what we have going on here. We have very interesting material here to present. We even have a webinar completely dedicated to this. So I think you guys are going to love what we have for you. So the most important thing to highlight here is that for a blockchain to be robust, it cannot allow any type of manipulation by entities with a lot of money. So what does this actually mean? So a blockchain needs a strong governance that allows a platform to update either the code base, the data structures in the platform, or even the network. Let's say we want to add new nodes. Usually how you do things is you have one user, one vote. Now, this is way easier said than done because it requires everyone to vote. And as we've seen on other platforms, what usually ends up happening is a really low voting turnout. So another problem that appears with this solution is that the parties with a lot of money can start buying votes to manipulate the decisions of the network. And if you don't really solve this properly, you're essentially back to square zero because you're a proof of stake platform. Can we go to the next slide, please? So here we're just showing exactly like the role of governance in our system, the type of changes that we envision that will probably take place. So we will be adding new nodes, removing new nodes, adding more sources of user identity, even like potentially changing the software of the network. And then the proposals that take place in the platform actually change according to the importance. So we might have to like apply changes to token economics, change to governance, and like the platform supports all of these changes. Let's go to the next slide. All right, so to properly solve this governance problem, we need a system with secret ballots that scales with the complexity of the issue. So for example, a small code base should only require a smaller number of voters than, for example, changing the entire block structure. On top of this, we need to stop vote buying. And we actually have that. We call it random sample voting. It was introduced by David a couple of years ago. It's purely peer reviewed. It has already been used, as you can see here, at the World Forum for Democracy in 2017 in France. And I'm actually going to explain in the next slide how this process actually works. So first, we require a good random beacon. And turns out we actually have that. As we'll explain in NodeCon, we have very strong randomness that allows us to select small committees to make very important decisions in our platform. So using this voting mechanism, we can actually solve the key turnout issue because we have way less voters to take very important decisions in our platform. The team in our company has already run many elections previously. One example, was an actually US election in Tacoma Park in Maryland a couple years ago. Next slide. So how do we stop vote buying? We introduced the notion of decoy ballots. How do these ballots work? These are completely indistinguishable ballots that any user can request and then sell to whoever is trying to buy votes. So essentially what this allows is users to sell votes that will not be counted in the actual election. So you're basically mitigating any buying efforts because the vote buyers will just literally be spending money. There are multiple papers that support that this is actually a very efficient solution. We are presenting here one of them. This is extremely interesting material. And it's very important to mention this in our platform because this is also part of the incentive model. You are not only incentivized to vote, but you ironically are also incentivized to sell votes because you can sell fake votes to vote buyers while keeping the integrity of the elections.